Hello everyone, welcome back to my channel, Inain's Forensic Classroom. Today we are starting something really important, forensic foundation concepts. So these are the core ideas that make every other topic easier to understand. Whether you study forensic physics, chemistry, biology, fingerprints, documents, anything, these basic concepts will help you see the whole picture clearly. So in today's video, we are going to break down three simple but powerful ideas. The first is class and individual characteristics. Then we will discuss what is identification and comparison. And then we will move on to the reconstruction and analysis. So these are basically the building blocks of how forensic scientists think, how they solve crime, and how they connect evidence to the truth. So let's get started. So let's talk about the first one, which is class and individual characteristics. See, when we examine any piece of evidence in forensics, it's almost like, listening to a story. But before we understand what happened, we first have to understand what kind of evidence are we dealing with. And the very first question that we ask is very simple. Does this evidence belong to a big group, or it can be linked to one specific object or person? So this is exactly what we mean by class characteristics and individual characteristics. So let's start with class characteristics. So class characteristics of an evidence particularly mean whether they belong to a particular group or a category and not to a person. So it is not specific. So think about this in your everyday life. For example, if I tell you that someone is wearing white sneakers, okay, now that doesn't tell you who the person is, because there are thousands of people who wear white sneakers. So white sneakers is a class characteristics. It describes a category. Or for example, imagine you found a red pen in your classroom. So many of the students in your classrooms would use red pens, right? You cannot tell whose it is. Again, it belongs to a group, not a specific owner. Now relate this to forensics. A blood group, for example, blood group A positive or B negative, it tells us the category but not the person, because there are a lot of people who have the same blood groups. Okay, so class characteristics helps us to reduce the possibilities, but they cannot give us a perfect match. Now moving to the individual characteristics. So these characteristics of an evidence are unique. They are one of a kind feature that points to a single exact source. Now think of it this way. Imagine you break a mug, okay? Now, if you take the pieces of the mugs together and they fit together perfectly like a puzzle, so that perfect fit is what we call an individual characteristics. It is so precise, so exclusive that it can only belong to that one object. So in forensics, we see the same idea everywhere. For example, if a bullet has a striation marks, so striations are basically the tiny microscopic lines that are carved by a specific gun barrel. Now, two barrels will never leave the same marks. So it is an individual characteristic. Or for example, fingerprints. Not a single person share the same pattern of ridges and minutiae. Okay, so that is the power of individual characteristics. It is very simple. Class characteristics tells you the group, and individual characteristics tells you the person or the exact object. That's what makes them so powerful in crime scene investigation. Now moving on to identification and comparison. Now let's talk about identification and comparison. So these two words would sound similar, but in forensic science, they do totally different jobs. So see, identification is basically the first step. So this is simply figuring out what something is, what it is. So if you find a white powder, so you test it to see whether it's sugar, salt, or cocaine. Or for example, if there is a stain on the floor, you check whether it's a blood or paint, right? So identification basically answers one question: what category does this evidence belongs to? Okay, so see, identification is only the beginning. Then comes the step 2, which is comparison. So this is where things get interesting. Comparison means checking whether two things match with each other. Two things match. So for example, if you have a fingerprint from the crime scene, you match it with the person's fingerprint. Or you may answer the question like, does this bullet matches the bullet fired from a seized gun? Or does the DNA profile match of the suspect's DNA match? Now, comparison answers the big question here is, do these two samples come from the same source? So identification is knowing what something is, and comparison is about knowing who it belongs to or whether these two things are connected. Then moving on to the third point, which is reconstruction and analysis. Now let's talk about something that sounds very scientific, but it's actually very interesting: analysis and reconstruction. So this is basically how forensic scientists move from tiny pieces of evidence to the full story of what happened at the crime scene. Now, when we look at the analysis, it is basically the lab part or the science part. So analysis is the part where everyone imagines when they think of a forensic, for example, microscopes, chemicals, lab tests, and all that cool stuffs. So this is where you can take a piece of evidence and you scientifically test it. You test the evidence. Okay. Analysis answers only one question: what does this evidence show on its own? For example, if I am testing a stain, so maybe I would conclude that yes, this is a blood. Or if I am testing a white powder and it comes out to be cocaine, or I'm checking a bullet and I would say that it was fired from this gun. So see, analysis is limited. It doesn't tell you how the blood got there. It doesn't tell you how the fight has happened, how many shots were fired, who has attacked first. It only tells you the facts about the evidence itself. And that's where the next step comes in, which is a reconstruction. Reconstruction is basically putting the facts together to rebuild the story. So once you have the scientific facts from analysis, you will build a story around it, and you now ask, how did the crime happen, or what sequence of events does the evidence support? So reconstruction basically uses your lab reports from the analysis, also uses the witness statements, photos from the crime scene, position of the objects, injuries, blood patterns, everything, and combines them to rebuild the story of the crime. So analysis tells us what the evidence is, and reconstruction tells us how it happened. So this brings us to the end of part 1 of our foundational forensic concepts series. Today we decoded three major ideas: class and individual characteristics, identification and comparison, and reconstruction and analysis. And these ideas may seem basic, but trust me, once you understand them, everything else becomes so much easier to understand. And in the next video, we are moving into really interesting side of the foundation, the part most people don't know actually exist behind every lab report. So these concepts that we are going to talk about in part 2 are really important, so make sure you don't miss that video. Also, if you're enjoying my videos, please make sure to like, share this with your forensic friends, and of course, please subscribe to the channel if you haven't already. It really motivates me to keep making more content for you all. I'll see you in the next video. Bye.